Well, hi everybody. So we have 25 people next to me and Ramon joining. So that's very exciting to see at the first exploratory meeting about aerial robotics in ROS. I reached out a while ago into the discourse thread, and a lot of you responded to that. So I was quite happy with that. So Ramon and I. Um, we're like we said before, very interested in what the aerial robotics community is in ROS. So just kind of a quick introduction. I'm Kimberly McGuire. I'm currently working at Bitgrace, which is a company in Sweden, and we make the small crazy fly, if you know of that. Yeah, and Ramon.
Hi,
Uh,
my name is Ramon Roche. I'm the general manager for Drunko Foundation, and I've been at this job for the last 6 years and working with drones for the last 10. I'm happy to be here with you and excited that we're getting this kicked off.
yeah, great. So I think probably I'm glad now that I prepared some kind of presentation. So I think just to kind of show kind of the agenda of today, I think the whole meeting is probably going to last about an hour. And also in an hour, I have to leave to go for my boxing class. So cannot last longer than that. That's a very hard deadline. But we would like to start first with our introduction. What is our motivation of the outreach of ROS2 community, and perhaps also kind of get some kind of discussion going, the motivation to motivation to use ROS for aerial robotics, to use to hear your use cases, and what is the current solution for ROS2, what is missing, what can be better, and of course next steps, what do we want to get out of this in the future. So just some stats from the discourse thread that I've started about gauging the aerial robotics community. Because there was quite some people that actually answered, and on the questions that I posted there, which was like, okay, what was your name and affiliation? I'm not going to put all the names here, but just the general statistic, like which aerial platform do you use, which autopilot, which ROS package are you used to, and what are you missing currently in the ROS framework. So this is kind of like an overview to kind of get started, but I'm more hoping now, or we're more hoping that we'll get some more like one-to-one person discussion going. But this might be a little bit of a primer of the stat that I've made so far. So as I saw, at least from the answers, is that 60% is from industry, 30% is from academia, and about 10% said that they were hobbyists. And all kinds of aerial platforms are being used, multicopters, wings, VTOL, octocopters. Yeah, I haven't seen any flapping wing MEVs, but let's see in the future. And of course, PX for Autopilot is the biggest. But some of you do use Autopilot or the DJI SDK or the Crazy Fly. And most of you are probably also know the most about the MAV ROS for ROS1. Have probably already experienced with navigation stack, nav1 or 2, and or have made their own kind of aerial robotics navigation stacks. So, and kind of the 4 points that I got from at least the thread at the point that I started counting, there's a wish for better integration between your autopilot and ROS2. I want also for less bridges. Some have already started their own autonomy stack for aerial robotics, and also a need for standardization. So let's get started to at least me and Ramon's motivation to have an outreach for the ROS2 community. I don't know if anybody of you were actually at ROSCON yesterday. If you do, thumbs up. I gave a talk there about integrating the Crazy Fly with ROS2, and actually that was a great experience of getting that project on, of having all the possibilities of connecting at least a flying platform to all kind of the great navigation stacks and mapping stacks and simulation stacks that are already out there. In the ROS framework, because think that you don't have to reinvent the wheel. And I just love the ROS community in general. And I was, as Ramon said before as well, when we organized a meetup at ROSCON last year, we were amazed with how many people showed up. And there's not even an official aerial robotics work group in ROS. So yeah, that is kind of like a bit in a nutshell why we started to have the motivation to outreach of ROS for the ROS2 community. Also, that's at least between the Drone Code Foundation of PX4 and the Crazyfly, ROS2 is a very nice way to kind of combine, yeah, let's say our shared effort. Let's say the Crazyfly doesn't use PX4; it has a port though. Yeah, at least like that is what we also saw as a nice tool for collaboration as well. So that's at least what's. I hope you can add something to that as well, Ramon.
Yeah, definitely. So my motivation is to actually find where all of our paths convene and see if we can actually find ways to solve common problems. I saw the post on Discourse, and I saw a lot of the common problems that we're currently been having, um, especially on our corner of the world with PX4 and drone code. And I gotta say, I think things are getting better, but the road to get to where we all want to get to, the only way to get there is if we all pitch in, and we need to raise the issues and actually get to work together to address those. And yeah, so that was my motivation, actually getting started with the work group and getting everyone's feedback and seeing if we can align on a roadmap to get to the best ROS2 experience out of the box possible for any aerial robotics platforms that we can put together. In terms of PX4, we recently introduced a micro DDS interface based on the XRC DDS by Proxima, and we are targeting ROS2. And that's a new interface and has some documentation already available. I encourage you all to check it out. But I think the road still has a few more miles to go, and it'll be interesting to actually start seeing the use cases for ROS2 in the aerial robotics community. So that's what I'm most excited for this talk today, is see and listen from you what your experiences are, what your use cases are, what are you actually working for, and seeing if we can actually address those use cases right now with what we have, and if not, building those interfaces so that we can address them.
Right. That sounds great. Yeah, so I have a couple of, as I mentioned before in the agenda, a couple of discussion points that could perhaps kind of get us started. As we said, we weren't expecting so many people today, but we really want to, of course, also hear from you. So I have a couple of discussion points per slide. And of course, yeah, so sorry, yeah, if there's any questions so far about what we just said before, please go ahead.
Yeah, or anyone else here who wants to open up your mic, feel free to do so right now. We're at 28 people, right? So it might be hard to do introductions for everyone, but if anyone wants to.
Yeah, I'm afraid that we don't have enough time for that. But perhaps, like, if anybody has a question, they can just do a very one sentence introduction. Perhaps it's handy to actually use the raise hand functionality that's underneath the Google Meet to kind of manage things, because 28 people is very difficult for everybody to speak at the same time. So especially with the discussion parts later, that I think we.
Yeah, I think it would be nice to understand who from the call is actually using ROS2 with any aerial robotics right now. Like you said, everyone, is it just a few?
All right.
There we go.
Was that somebody wanted to say something? Oh no, yeah, this raising hands. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I see, so about 8 people raising their hands for ROS2.
Awesome.
Or
what about ROS1?
1 month.
Yeah, no.
Will be less now, or
About the same
about
so
the
far.
same. Yeah, 1, 2, 3, 4. 9. Ah, that's actually, yeah, I would say about the same,
Yeah.
perhaps, right?
Okay.
Yeah,
Good. Thank you.
I think
All right.
it's, yeah. You can all unraise your hands now.
All
That's
right. So, anyone here that is actually exploring the idea of using ROS2 for any aerial robotics projects that hasn't yet started? Actually, that's actually really interesting. Thank you.
All right, so we have about 4 for that. Interesting, interesting. All right, thank you. Okay, so then let's give us a little bit indeed for a primer. You can all lower your hands again if you want. Okay, cool. Let's go to the next slide. There's nothing on the slide.
Discussion time.
Discussion time.
And I'll take notes for this one.
Yeah, sounds good. So we would like to kind of hear from you. So if anybody would like to, yeah, of course, like, to pitch in any of the ideas that I'm going to present today, or any of the prompts that I'm going to present today, go for it. But you can of course also use the chat, and then we'll just announce your question in there, and then we'll just have a discussion with whoever is interested in that.
Yeah. Well,
So
let's get started with the people that are interested but haven't started working in yet, and maybe try to understand what their questions are and see if the data that is available out there, online documentation stuff, is actually enough to get started with the project.
yeah, that's a good one. We didn't have a slide about that, but that's perhaps a good prompt to get started out. Or is that does it have anything to do with the motivation to use ROS for aerial robotics? But I guess your question is about, is it easy to get started in ROS 2?
Yeah. For the
Yeah,
people that
okay.
haven't yet started, how easy has it been so far to figure out data about aerial robotics and ROS?
All right, we're going to.
Anyone want to open their mic?
There was one raised hand from Ayam. If you want to, yeah, if you want to open your mic, you can go ahead.
Sure. Can you hear me now?
Yes, we can hear you.
Great. So first of all, thanks a lot for the invitation and organizing this. I was really excited. Thanks, Ramon, for sharing it at the PX4 Discord. A small introduction. My name is Ayham. I am a researcher at Saxion University of Applied Sciences in the Netherlands. And a lot of my colleagues, I'm glad that you're recording, because a lot of my colleagues are attending Amsterdam Drone Week, and they couldn't attend this meeting. So probably the number will go up if it wasn't Amsterdam Drone Week. One thing about getting started with ROS2, I think I got started with a couple of my students around a few months ago. It was a messy time because I'm using mainly PX4, and with PX4 was migrating from using RTPS bridge to micro DDS. And it was a little bit messy at the time, the lack of documentation, but you can understand the lack of documentation because it was a work in progress, of course. And one thing I think that we can improve a little bit about using ROS2, I think, is about better, let's say, connecting releases with so it can be ROS2 release or a certain PX4 or some other flight control stack release with a certain releases of ROS2, Gazebo, and the toolchain. I think me and my colleagues and my students, we always have the same problem, that we are running into a lot of compatibility issues in the toolchain. I think, and for someone who's just getting started, it can be very, very confusing. What is going wrong, and how can I fix it myself? How can I learn how to fix it as well, just to know what's going on? I think that this kind of I think software, more oriented software people can say more about this, but probably there are some tools that I know of as Docker, but probably we might need something a little bit better, maybe documentation, maybe tools. But that's some experience about getting started with the ROS2 in the transition phase.
All right. Yeah. So I guess it's you need to be like quite a good developer already to really get started. You're saying, yeah, that's. I think probably in ROS2 and the UFVs, there's a lot to improve in that sense. And but I guess that's kind of like the reason why we are interested in how the current state is. Yeah, I don't know, like Ramon's, like if PX4 has any like good you guys actually have some documentation to get started on ROS.
Yeah, but it definitely can be improved. And I think to I am point, there might be more than we can do to make it clear which PX4 release supports which ROS release. Yeah, it can be more clear. Kim, just a quick thing. I think there's people that are waiting to be admitted in the call still.
Yeah, but I actually didn't see any admissions, so I'm just double checking. But you go ahead with the discussion, and I'll try to see
Sounds
if
good.
I'm able to do something about that.
All right. Thank you, Am, for your contribution. Anyone else want to share with the team, with the group? There's a few messages on the chat already. Fred, you want to open your mic, or Adam?
Yeah, I'll go ahead. This is Fred. Yeah, I just put a note there just so you guys could see what I'm planning. I fly multiple vehicles in various configurations. Probably the most significant one is a single rotor that weighs upwards of 900 pounds. All the missions so far have been just GPS waypoint missions with, sensors to assist with landing and whatnot. And the current goal is to, implement ROS2, NAV2, and cost map layers. I can't say I've really run into any significant trouble. I usually test on a small quad. I think the biggest hurdle I've found is really finding small compute platforms, that are small enough to test with on my quads, that can handle, the compute necessary for ROS2, NAV2, and these various cost map layers. So still a learning curve for me. I'm not an expert at it by any means. So I just wanted to really let you guys know what my current goals were, if it helped in planning or direction.
Thank you, Fred. In terms of small compute platforms, what are your requirements other than being small?
Well, certainly I don't have any requirements for small and the big machine. With its weight and capabilities, I could take anything I wanted. But for testing, it takes small stuff. I've like many people, Raspberry Pis and so on. I've got those in abundance. Some of the NVIDIA stuff, seems to work well, although it does seem to take a long time to get things built. As far as the software goes and the stack being exactly right, it seems to be a bit sensitive. And a lot of that is due to my learning curve as we move forward. I expect that'll get better.
Thank you, Fred. That's really valuable. I'm working with some hardware manufacturers right now to actually address that problem, because it's a known issue for a few months now.
All right. Yeah, so I'm not able to see anybody in the waiting room, by the way, in terms of letting them into this meeting. I've turned something off, so everybody has to ask for permission to get in. So if anybody that you know of is trying to get into this meeting room right now, just ask them to get out the waiting room and get back in, and then probably I can let them in. So it's it's a bit magic this sometimes. So
We got time for one more question. One more for the group.
We do have a couple of messages in the chat, by the way. I don't know if you noticed.
Yep, Adam Garlow, do you have time to open your mic?
Sure, I can talk real quickly if you guys can hear me. I'm a graduate student at Georgia Tech, and our lab is trying to move to this ROS2 PX4 framework. And I think it's a similar sort of concern some other people have mentioned here, where on one hand, we're really excited that PX4 is actively supporting a move to ROS. On the other hand, it can be a little bit difficult in that every new version of the software, like things can break with like message definitions, moving to the new micro DDS, and we sort of end up tracing through the GitHub comments and pull requests, and there's people talking about, well, let's actually put a pause on this and like go to a full API and move away from the bridge entirely. And I guess my one piece of feedback would just be, it would probably be useful to many people to know, like, should I stick to a particular version of the PX4 code base and just work here, or like, are we moving to this new system and new features, like some sort of timeline as to like where should we try to adopt, and like sort of what should we try to build around? Because it, on one hand, it's like a double-edged sword. We really appreciate that it's so actively supported, but on the other hand, it can be tricky to know like at what point should we jump in, because we're trying to move out of sort of the simulation world and into the actual hardware implementation, and that's where we found that things can be a little bit more tricky. So.
Awesome. Thanks for the feedback, Ben. Ben, do you want to speak up?
Sure. First thing I was going to mention to Fred is I pasted a link in there for something that you might be interested in the chat that you can look at. That is a great solution for those of you looking for something that can run Ubuntu through a Yocto Skim-based build that you can do full apt installs with. A lot less painful than all of my Jetsons that I have now collecting dust around me, or my Intel Nooks, or any of the other things that people typically have to deal with to not be tortured. And then on the other side, I think I want to be careful from our presentation of this. I know that our Drupalot people use ROS2. I don't know if there's anybody from our Drupalot on here. I know some of those users are in different time zones. And there's a variety of people that use ROS2 and Aerial Robotics outside of, say, the specific toolchain / message builds associated with PX4 exclusively. On our side, we're doing a more direct route where we're utilizing Zeno Pico, which should have stability by end of Q2, to basically send messages directly across. We're building ours on top of course, Zephyr instead of NutX. So we're utilizing ZBus to Zeno for basically pure streamlined communication with pretty much no overhead. That also allows us then to write a connection. We chose Gazebo as our simulator, and we have a connection that allows us to go directly from Zeno then into our protobuf ZMQ for Gazebo, so we can do hardware in the loop simulation. So that seemed to have been working pretty well for us for what we want to do. Our goal is to keep our messages, though, as core to the fundamental underlying use, versus trying to adapt it to sort of more existing message framework of, so for instance, we implement a direct actuators message, and we like that sort of path. So I think that what interests us, at least in these kinds of conversations, is finding where there might be useful, beneficial overlap on defining ROS messages that might be beneficial outside of any of the existing set for everybody to utilize in a framework. We won't be implementing Mavlink intentionally for anything ROS2 related. I don't know if anybody here does do that right now or plans to do that, but we just view that as an extra translation layer that's really not needed, as most of the base types are already existing in ROS2. And so that's sort of our interest in joining this call. I don't know if anybody else has interest in that as well, though.
Yeah, we'll indeed see if there's more people involved or at least interested in the same topics. But thanks for your 2 cents on this as well. I think perhaps it's good to go to the next discussion topics, because we're already in a half an hour. It goes fast when you're having fun, right?
Thank you, Ben.
Yeah, thank you. Yeah, I guess like this kind of already went a little bit into like, motivation to use ROS for Aerial Robotics. I guess like we kind of start like, how difficult is it to to work with ROS and peaks for ROS and Autopilot. But why would you even want to start with ROS in the first place? Like, what does ROS mean to you, and why do you want to? Or like, why won't you just focus on your own Autopilot? Why do you also want to involve ROS in that as well? So, who wants to start? Hands up. Everybody is agreeing that ROS is awesome and everybody should use it. All right.
Go
We
ahead,
have a
Am.
raised hand. Go for it.
Yeah, so I think the main reason for me to use ROS2 is, again, I'm not a developer by training, which means that I need something that I can wrap my head around it without a lot of with, let's say, a smooth learning curve. Especially that it's not my intention to be a developer. I'm using it as a tool to access the robot and its simulated model. So for me, ROS and ROS2, of course, it seems like the obvious choice since it's open source, supported, a big community, and a lot of tutorials to guide me through it. But also now with my students, it's also the same thing that I can I can be sure that if they run into some problems, they will probably find some support online about how to solve them, and that's the problems related to ROS and ROS2. When it comes to integration with the flight controllers stacks, that's a little bit different story. I think the idea behind let's say the ROS choice or selecting ROS for aerial robotics, it is mainly that it is as close as it be for out of the box solution, let's say, at least a personal opinion.
All right.
Thank you, Am.
Thanks.
Pierre?
Was Pierre? I think you had your hands up.
Yeah. So it was mostly already said. So I belong to Autopilot. I was doing some freelance job on the past few years, and what I learned is like people are mostly using ROS with UFA because it brings some interesting API to program the drone. So it's like a kind of simple interface to make some programming on the drone, and most of the time you don't need the full ROS to do this. That's because it's the most convenient stuff we got.
All right. Yes, that's indeed also a good reason. Anybody wants to give their 2 cents on why to use ROS for aerial robotics?
I mean, I think it's in part the clean separation that you can get is the reason why we've looked at it in between upper level flight computer and then having a distributed layout for your control side of it. So we use only our embedded side as real-time hard dependencies embedded basically on a CAN network is what we're implementing it all on. And we don't care to have any higher level anything running at all on the embedded side except for basically inner loop and some other basic safety controllers. And besides that, everything we keep on our actual compute boards. And I think that's where ROS comes in handy because of the nice RMW that you can implement. So really it comes down to what is ROS2's value, and I would argue it's RMW and modularity.
Yeah, thanks,
Awesome.
Ben. Indeed, the modularity is a very interesting aspect of it as well. Yeah, cool. We have 2 more. I think Fred, go for it.
Yeah, I'll just go ahead and say Ben really answered nearly word for word what I was about to say. It just comes down to keeping, flight dynamics as close to the flight controller as possible, but really everything else I'd like to keep modular. I like the message, the kind of the message bus, framework. I like frame translation. All external actuators and so on benefit immensely from from frame translation, and as I said earlier, I'm really hip on cost map layers to merge the inputs of many, let's just call them spatial sensors, for obstacle avoidance and so on. So I don't know if that helps much, but that's my interest.
Yes.
Thanks, Fred. Helps a lot.
Let's see, there was one more. So go for it, Arj.
Yeah, so we use mostly ROS for connecting and multiple robots. We have different kind of robots, so it makes easier to communicate with them. It makes easier to transfer the messages from DJI to Crazyfly or Crazyfly to Turtlebots. So mostly we work with the academia, and we have bunch of Crazyflies, uh, several different types of drones from DJI, Parrot, and some ground vehicles. So yeah, plus its modularity makes it easier for air vehicle to use with ROS.
All right.
Awesome. Thank you, Arsh.
So I guess maybe to kind of give a little bit of summary, I guess like modularity, I've heard that come quite often. The community aspect of it as well. I guess like, trying to separate anything that is just flight based with anything else. Yeah, kind of like the general concept of it. So I guess we'll try to make some notes of all of this, but you guys are
I
giving
have been doing so. It just
Yeah.
doesn't update it on your screen. I don't know why.
Yeah, exactly. But I think yeah, of course we have also the recording to kind of listen to in case we're forgetting anything because there's so much information. But thanks for sharing. So let's go and move on to the next discussion topic. I guess we already heard your use cases, perhaps.
Well,
but if anybody would like to share,
it would
yeah.
be interesting to hear from the ROS1 people first.
Yeah,
So for
go
those
for
of you that are using ROS1 with Aerial Robotics, what is your use case?
I can go ahead. As far as the AeroVironment, ROS1 is being used in their autonomy stack. So they have their own flight controller, and then ROS1 is used on another compute box to perform mapping missions, surveying, and they even do some swarming with it.
Awesome. Thank you, Ryan.
Yeah, and that's on a fixed wing platform mostly for ROS1. And so we're currently in the evaluation stages of looking to use ROS2.
And just a question on that, Ryan, is because I've been hearing that many people would like to switch from ROS1 to ROS2. I don't know if you've started in any way, but do you find the transition, how you're like, how would you look forward to this transition? Do you think the port is going to be difficult to port your entire project to ROS2, or?
Yeah, so I worked at another company called Trimble that wasn't Aerial, but we did do a port from ROS1 to ROS2, and it really depends on the package on how heavily you tied your algorithms and everything to ROS1. So AeroVironment has mostly done a good job about keeping those concerns separated. So I don't think the port's going to be particularly difficult, except for the swarming applications. The networking is just really tricky to get that right. And it's going to take time to tune the DDS quality services. But that's not something specific to ROS2. That's more just DDS in general. It's going to take a lot of time to get that right.
Yes, I also had, yeah, I forgot to mention it as well, is that currently co-maintaining a project for maintaining, communicating with multiple Crazyflies at the same time. So the Crazy Swarm project, which is also kind of going through ROS1 to ROS2 ports right now. And I think I also had the question from my other maintainer about the communication with the AWS protocol. So perhaps we need to also have a multi-robot. Is there a multi-robot work group actually? I don't know. Or swarming mode. Perhaps that is more of a topic for them. But
yeah,
I guess yeah.
I've asked around like in terms of nav2, and it seems like that the use cases for multi-robot coordination are usually pretty application specific, and it's been hard to develop a centralized or a common infrastructure to support that, since the use cases are so varied.
Yeah. Okay. Yeah.
but maybe there's some overlap that could be developed, or there's not any recommendations in ROS2 on how to do multi-robot coordination in terms of how to set up your topic structure and your participants and your domains and all this stuff to enable that. So maybe that's some work that could be done as sort of general guidelines.
Yeah, that's a good point actually, because like I guess like the aerial robotics is like, it's so wide, and swarm robotics is also like, swarm aerial robotics is also a very big part. But then of course the question then, if that will be something that's requires a work group of its own, or something that is so important within aerial robotics that because communication is just very important. If that is perhaps something that we can also kind of see if we're able to guide in some way there. But it's a very good point. Thanks for mentioning that. I think we had I'm going to probably pronounce your name wrong. Is it George or George?
Jorge.
Yeah, it's Jorge in Spanish.
Jorge, yeah, okay.
Yeah.
I'm sorry. Go for it.
Yeah, just jumping in. So maybe one of the reasons for us also that we haven't fully, we tested this micro RTPS bridge and then the newer with more TDS integration that work better, but the networking, as you were discussing now, is one of the reasons that we are not fully using ROS2. So we are mainly doing multi-robot systems research, and it's much easier to do experiments with ROS1 still. Plus, some of the use cases include like 3D lidar mapping, so there's a lot more packages for ROS1. However, we just finished some experiments with a bunch of turtle bots, which we've been preparing for turtlebot force. We've been preparing them for teaching as well, and we've struggled a lot with TDS, even tried this TDS router and other things, and Xeno is what is working for us the best right now. I heard XenoPyco mentioned earlier. I mean, we can have 8 turtle bots and all streaming cameras, 2D lidars, and it works really smoothly. It takes a while to set everything up with Xeno, but it works pretty well. So maybe the next is that we try multiple drones and using Xeno. We discussed a bit this in Roscon also with this, I think it was Bristol Robotics Lab. There was a guy from there that one of the problems with flying drones with ROS2 is when the network becomes unstable or the connection is not ideal, then, well, the drone doesn't fly as well if you are offloading some of the computation to your laptop or some other computer.
Yeah.
Awesome.
Yes.
Gracias, Jorge.
Yeah, it's only about 15 minutes left. So if there's not any more use case, or do you have another question, Ramon, yourself?
No, I think the use cases are the more important part. So let's see if we can squeeze another one from the group.
Of course, yeah.
Okay.
I see a hands up, so
I am.
Go for it.
I think my use case is a little bit different from what is out there, so it might be worth noting. What I'm mainly working on, and our group is working a lot in this field, is aerial physical interaction. So in this sense, we are developing aerial manipulators, and we're developing, let's say, drones that can do physical interaction tasks, and this requires most of the time that we're developing our own controllers. So we need to have low-level controllers that can handle physical interaction. And you can think of impedance control, NMPC, and these kind of advanced controllers. And our struggle is that most of the time, the straight connection to the flight controllers, so in my case it's PX4, it is meant to kind of shield the end user from using the actuators directly, from accessing the motors directly. There's a lot of safety layers, understandably, of course, and this is one of the struggles that it is motivating us maybe to use ROS2 more, because eventually we would like to access the actuators directly, and we would like to know exactly what's going on in terms of what is going on with the brushless DC motor, in terms of the feedback and so on, coming back from the ESCs. So in this case, I think we're struggling a bit that most of the solutions out there, they do not address this use case because most of them, they rely on you telling the controller basically a set point. And in our case, we need to modify the controller itself. The controller that is in the flight stack is not really useful for our use cases. So this is has been a little bit of a struggle, and probably also because of lack of expertise in my or our software development skills, it made it a bit harder as well.
Yeah, so to kind of like you would like to be able to see more feedback from the actual
Yes,
autopilot controllers, indeed. So like not being shielded from information that's happening on there. Yeah.
and also control the actuators, whether they are the brushless DC motors in our case, or some other auxiliary payload. Be able to access them directly, as in like send commands to them, whether it's PWM or whatever. Send commands to them directly, and maybe if they provide any feedback, also access it directly, so that we can use that in control.
Yeah. All right. Yeah, that's a very good point. Yeah, it's dependent on the use case, I guess. Like some would just go for the low level control and just like just fly. But yeah, if you would like to have direct access, but yeah, at least like for the crazy fly, we see a lot of these use cases at least coming that either they want to use it for direct motor control, or they will just want to use for direct autonomy. And the ROS layer is going to make that a little bit more difficult, because then we got to choose from the firmware which is going to be opened up to ROS and vice versa. So it's yeah, good point though. Good point. Yeah, so that's why we're here, right? So to hear all about this. I'm trying to give I've refreshed the slides a little bit, so it seemed to at least have your notes there now. So is there anybody else that wants to say anything about their use cases?
Any ROS 2 use cases right now? Not limited to ROS 1 anymore. Doesn't need to be a PX4 or anything. It's just anything that's being used in ROS 2.
All right. I think that is probably. Oh, we have a Pierre.
Pierre, go ahead, Pierre.
Yeah, so I got a small point. I think I'll write it on the chat. It's something with ROS and simulation. So currently on ROS, we got a lot of way to simulate drones. We got like gazebo by simulation, rotors, RDPilot1, Pix41, and we don't have a central place to like kind of a wiki on how to simulate drone with ROS. And this is kind of lacking because we need to go on each project to find a simulator, and I think it could be useful for us to have a wiki page dedicated to drone simulation.
Mm-hmm.
Yeah.
So
Thanks,
so yeah, I know that the PX4 documentation has a nice list of simulators that they support. But I guess you want to have a ROS2 specific documentation about aerial simulation.
Yeah, so something on ROS wiki, because yeah, we can go on Pix4, we can go on RDPilot. I think that would be crazy. You got maybe something for simulation, and if you got on, I don't know which other you have a project, you got some simulation with ROS, but there's no control place on ROS on how can I simulate a drone.
Yeah. Okay. Yeah.
So something like on ROS specific documentation.
Mm-hmm. And you don't mean like, for instance, a separate page, like for instance the nav2 and or the STEM toolbox people are doing it. So like I think like for instance the navigation ROS2 stack, they also have their own web page as part of the workgroup, I guess, where they also put some tutorials as well. Do you mean something like that, or would you rather want to see a tutorial really on the on the
Yeah,
ROS.
it can be just a really page where we list some things we know that are working, some big projects that are working with ROS, and just say, okay, you can go to this page and get some clue on how to simulate a drone with like Pix4 the pilot or whatever.
Or at least point you to the right direction.
Yeah. If you're not looking on internet, but you can.
Yeah. Okay. Yeah. Okay. So that's that's a good point. Yes. That's let's see how much time we have. We have about 9 minutes left.
Yeah, and I also have a hard limit. I have another meeting.
Exactly. So like for everybody that's here and wants to have was it the community call that's in 9 minutes or?
Yep.
Yeah. Okay. So the community call of the PX4 is going to be in 9 minutes on the Discord channel, not Discourse, but Discord. So that's why we also have to stop soon as well. But I think it might be better just to maybe go to the last point of our agenda. Because we already heard a lot of good use cases and I think that was very useful, but I don't think we'll be able to finish off all of our discussion points today because of the sheer amount of people that showed up, which is completely fine. Like, we're absolutely happy with this. But perhaps then it's good to kind of transition to, I don't have a slide for that. So I'm just going to say it. So like, perhaps hands up for everybody that's would like us to do this more regularly, a meeting like this. So.
All right.
Almost
Good.
everybody.
I think you can just say yes.
Yeah.
Yes. Yeah. So I guess before already on the discourse thread, it was already really noticeable that like standardization and guidance and just perhaps just a place to collect information about anything ROS and aerial robotics related is something that people like seem to want. Yeah. Okay. So yeah, then that's like, I'm game also for kind of like helping out with organizing these occasional meetings. Maybe not in Google Meetup, but let's see how we can solve this. Because first of all, we just want to see if people were interested, and I think people are interested, don't you think, Roman?
Yeah, definitely. So based on what we discussed today, I think I'm going to go look at the answer for your questions again and try to come up with a list of things that we can tackle together. I think the one thing that Pierre identified, which is a lack of like a summary page for ROS2 and Aerial Robotics, like this is all the things that are supported. Like maybe we should get started there, see what we can actually put together. And then let's tackle all those individual issues, the integration issues, and see if we can standardize around ROS2 for all the different platforms, Crazy Fly, DJI, MapLink-based flight controllers and everything, and see if there's anything that we can do together to get to that ROS2 Aerial Robotics nirvana that we're all craving.
Mm-hmm. And I guess, yeah, so perhaps because I think like I'm not from Intrinsic myself. I just saw somebody from that asked that question. But what we can, for instance, do, if we can put in a proposal at Open Robotics / Intrinsic to start up an official aerial robotics workgroup. And if there's enough merit for that, then they will probably accept that, and that will be not exactly sure on the exact process of that, but at least that will be promoted on their website, and then we're like, allowed to be associated with ROS as an official work group. And I guess we can just maybe perhaps just keep this going since there's so many people. So like, I don't know if you would like us to maybe have like a monthly meeting, or like every 2 weeks. Every week maybe it's a bit too much, but
yeah,
I don't know.
I would go for monthly.
What is a good frequency, let's say? Sorry, Ramon.
Lots of them are just monthly meetings. You should probably just follow what most are for TSC meetings, which is monthly. If people need to meet sooner, they can. And I think maybe we turn off recording at some point for those who want to share their info. If other people have questions, it sounds like there's some similarity of process of what people want to do. So I think we're past the useful recording phase right now.
Yeah, sounds good. That's a very good point. Okay, so I'm going to stop the recording right now. Where's the button? I haven't stopped recording.
Yep.